So I overheard a conversation this week, and a guy was talking about his new 6.5 horsepower shop vac. Unfortunately, he is falling victim to misleading marketing. So let's dig in and find out why this marketing is misleading and why it is not true. Let's go ahead and use my shop vac as an example. So as you can see here, my shop vac is rated at 5.5 peak horsepower. So first we need to understand, how do we turn horsepower into terms of electricity? Well, 1 horsepower is equal to 746 watts. And watts is nothing more than voltage times current. I have several electric motors around the house, so let's go ahead and take a look at a few of them. So here's one that's rated at 1 3/4 horsepower at 115 volts and 15.5 amps. So if we plug that into our equation, 115 volts times 15.5 amps equals 1,782.5 watts. And if we take that and use a conversion from watts to horsepower, it comes out to 2.39 horsepower, which is greater than the 1.75 stated horsepower. Here's another motor that I have. It says it is a 2 horsepower motor at 240 volts and 9 amps. So if we plug that into our equation for watts, 240 volts times 9 amps equals 2,160 watts. Then if we multiply that by the conversion from watts to horsepower, we see that it comes out to 2.9 horsepower, which again is greater than the 2 horsepower that is stated on the data plate. So why is the calculated horsepower much higher than the data plate horsepower? Well, the data plate horsepower is output horsepower at the shaft. By design, electric motors are approximately 70% efficient. So let's go recheck this data, accounting for 70% efficiency. So the motor we looked at, that was 2 horsepower, we calculated it to be 2.9 horsepower. And if we multiply that by a 69% efficiency factor, we get the stated 2 horsepower that is on the data plate. If we look at the motor that was 1 3/4 horsepower, we calculated that it was 2.39 horsepower. And if we multiply it by an efficiency factor of 73%, we get the 1 3/4 stated horsepower. So now that we know that electric motors are about 70% efficient, and we know how to multiply the voltage and the amperage together to get horsepower, let's see how much my shop vac really makes. After some searching on my shop vac, I did eventually find this small little label that shows that the shop vac consumes 11.8 amps at 120 volts. So we can go ahead and plug that into the equation for watts and take 120 volts times 11.8 amps to get 1,416 watts. And if we multiply that again by the watt to horsepower conversion, it comes out to about 1.9 horsepower. And if we multiply it by an estimated 70% efficiency factor, we can determine that the shop vac is in the ballpark of 1.33 horsepower. So now that we know that my shop vac makes about 1 1/3 horsepower, and it's advertised at 5.5 peak horsepower, we need to answer, what is peak horsepower? Well, peak horsepower is calculated by measuring the peak amps the electric motor draws in the fractions of a second after you flip the switch. And this is extra current that is needed to get the motor turning, but it is only for a very, very small amount of time, quicker than a blink of an eye. And so if we would look at a chart that maps current versus time, it would look something like this. And what the manufacturers are doing is they get this chart and they can pick the very, very peak of that initial starting current and say, oh, hey, look, we got 120 volts and it pulled 50 amps and boom, there we have our 5.5 horsepower. We're going to advertise our shop vac as 5.5 horsepower. So at 120 volts, an electric motor needs about 9 amps per horsepower. And there's the calculations if you wanted to take a look. Most 120 volt electrical outlets are designed for no more than a sustained 15 amps. As such, appliances with more than 1.5 horsepower or about a 13.5 amp draw are not common with a standard 110 volt plug. These motors are going to be designed to run on a 220 volt circuit. And so there you have it. Your shop vac is at best 1.5 horsepower. You may get up to about 1 3/4 horsepower, and those are designed for 20 amp circuits. 20 amp circuits are common these days in garages and in kitchens, but in older houses, they are a little bit less common. Hopefully you like this episode. Please like and subscribe. And as always, stay curious.